Pre-emphasis and de-emphasis, how it is going to be important at high frequency components, and we'll see the equivalent circuit diagram of pre-emphasis as well as de-emphasis, and how it is going to overcome that where high frequency component is being affected by the noise. So you see that pre-emphasis is going to be used in the transmitter and de-emphasis is going to use in the receiver, but pre-emphasis is used before modulation, de-emphasis is going to be used after demodulation. And apart from this, we are going to see what is the difference, basic difference between amplitude modulation and the frequency modulation. This is going to be the last lecture of this frequency modulation. Before that, already all lectures are available along with numericals. So still, if you didn't subscribe our channel, please subscribe it and share with your friends. So here we are going to see the pre-emphasis effect as well as de-emphasis effect, how improvement takes place in the system. Okay, so for that we are going to consider here power spectral density as well as average power due to noise. These two calculations we are going to see, and later we'll have separate series for the noise. In that lecture also we can see how we are calculating. Now here you'll feel it is new to you. These are expressions, but once we'll go through the lecture of the noise, then you'll understand how we are calculating this. So this power spectral density of the noise at where output of FM receiver. So at output we have, this is the N naught F square by AC square, where frequency modulus of frequency lies less than equal to W. That means it's going to be in the range where we have minus W2 plus W. And otherwise it is going to be the 0 here. So this is for the positive frequency as well as negative frequency also. And average power general formula is given as N naught F square by AC square into DF integral over minus W2 plus W. So this spectral density is being integrated over the minus W2 plus W to obtain the average power due to the noise. And here you can see this a spectrum of this. So they're having value here minus W2 plus W. Okay. And at the frequency, when we have this is the minus W and plus W, at this point you can see that amplitude is maximum. Okay. So that means higher frequency component is going to be affected more by the noise. Now here we have power spectral density of the typical message source. So that is in this form you see that for the message at higher frequency amplitude is less. So this power spectral density of that message signal or modulating signals or baseband signal is going to fall at high frequency. Okay, but what you are seeing that in case of noise, okay, that having higher frequency, okay, that having higher value at high frequency. So message is not using high frequency component. High frequency component used by the noise. Okay. So how to reduce the bandwidth? So that if we're going to reduce the bandwidth, we'll miss the high frequency components. Okay. But in case of music, that is high frequency components with low amplitude also going to play the important role. So it is possible to reduce the bandwidth of post-detection low-pass filter slightly to avoid the noise power, but we'll miss the important information in case of music. So overcome of this, separate circuit is designed that is called as the pre-emphasis in the transmitter and de-emphasis in the receiver. So you are seeing that pre-emphasis is used before the modulation, de-emphasis used after the modulation, and over the channel this noise is being added here. Okay, so later we'll see the expression that how pre-emphasis and de-emphasis response is going to be reciprocal of each other. So here at high frequency component, you have seen that message signal is emphasized before transmitter, and at discriminator output in the receiver, inverse operation is performed. What we are going to do for the pre-emphasis before modulation, opposite of this operation is being done in the receiver side to obtain the effect of the D emphasis at high frequency component so that we can restore the original signal. So it is used mostly where in FM radio. So now this frequency response of both should be inverse of each other. So for the D emphasis, it is written as suffix DE of F, and for the pre-emphasis is written as the P. So you are saying that as D of F equal to 1 by H P of F in the range of minus W to plus W. So this modified power spectral density of the noise at the de-emphasis filter is given as this spectral density is being multiplied by this square of the response of the de-emphasis there. So already we have n naught f square by ac square. It is being multiplied by due to the de-emphasis. So that effect we are going to see. So finally, that average output noise power. So when this will be integrated over the minus W to plus W, that is going to give us the average output noise power with de-emphasis. So now we are going to see what is the improvement due to application of the pre-emphasis and de-emphasis. So that improvement is given as the I, which is the ratio of average output noise power without pre-emphasis and de-emphasis divided by average output noise power with pre-emphasis and de-emphasis. So this is our numerator parts and this is going to be the denominator parts. So finally, that improvement you can observe here, we have 2w cube divided by 3 integral of f square as the E of f modulus square over the range minus w to plus w. So this is the improvement. Now we are going to consider one small example that if response of pre-emphasis circuit is given as 1 plus j f by f naught, then for the de-emphasis it is going to become 1 by 1 plus j f by f naught. This is how we are going to obtain, since de-emphasis, if you'll talk, it is going to be the inverse of pre-emphasis. Okay, so on the basis of this concept, you can see that here this one we can realize in this part. Okay, so pre-emphasis is this one, so that is entire this term is written here in the denominator. So finally, improvement we have W by f naught overall cube divided by 3 inside the bracket omega or W by f naught minus 10 inverse W by f naught. So if you are going to consider some particular condition where f naught is 2.1 kilohertz and W is the 15 kilohertz, then this improvement is about 22. So that is the advantage of this pre-emphasis and de-emphasis. Now, if you see in terms of circuit diagram, so in case of pre-emphasis, this input signal, that message signal is given here to the circuit that having parallel combination of capacitor and resistance. Finally, here at the output side, we have resistance, and from here this output is given to the amplifier, and this output signal is given for the modulation. Whereas in case of de-emphasis, we have demodulated signal as the input, and here you see that capacitor is connected in parallel in the output, okay, and resistance is connected here in the input side. So here we have demodulated signal, okay, which is given to the de-emphasis part, and this is the message signal which is given to the pre-emphasis circuit. So pre-emphasis is being done before modulation, de-emphasis is being done after demodulation. So this is the basic concept about pre-emphasis and de-emphasis. Later we are going to see how or what is the difference between amplitude modulation and frequency modulation. So this pre-emphasis and de-emphasis, sometimes short questions, sometimes long questions, okay? So short means only pre-emphasis or de-emphasis, their importance or circuit diagram or response will be asked. But in the long question, you have to discuss all these things. Now here we have comparison between frequency modulation and amplitude modulation. So already we have seen the standard equation of both, okay? And here we are going to compare. So many times this question is being asked as a long question. So amplitude modulation is the perfect regularity at zero crossing. Okay, and it has equidistance, whereas it does not have perfect regularity at zero crossing and not equidistance. So that when you have seen that when signal is going to cross the zero, that is the message signal, then how we are going to plot the waveform. That is not there in case of FM. The envelope of M is not constant. Okay, it depends upon the message signal. So that modulated signal envelope is keep on changing. But envelope of the FM is constant and it is equal to the carrier amplitude. And modulate in case of M, modulated in amplitude, and what will be the constant? Frequency in phase remain constant. Whereas in case of frequency modulation, frequency is going to change, but amplitude and phase remain the constant. So it has poor sound quality. AM has poor sound quality, whereas FM has better sound quality due to higher bandwidth. So here we have higher bandwidth in case of FM and lower bandwidth in case of AM. So here we are going to consider extend the range 535 to 1705 kilohertz and this transmission rate 1200 beats per second. Okay, that also we call as the baud rate. Okay, baud rate. So that is the rate of transmission of the data. And in case of FM, we have 88 to 108 megahertz range of frequency. On the basis of, you'll see that we have different FM in the radio or mobile also, like we have 98.3 FM megahertz. So these are the all frequencies in the megahertz. And here this baud rate is 1200 to 2400 beats per second. So almost very high here in compared to M. In case of AM, transmitter and receivers are simple, but synchronization is needed when we're talking about single sideband suppressed carriers. So that is synchronization. Same carrier signal should be used in the transmitter as well as receiver. And here in case of FM, this transmitter and receiver circuits are going to be complex. In case of AM, it is more susceptible to the noise due to amplitude variations. So here in case of AM, what's happening? Envelope is not constant, amplitude is going to change according to message signal. So it is not immune to the noise. So it can be affected by the noise easily. Whereas in case of FM, amplitude is constant, so it is less susceptible to the noise. So it has more immunity from the noise. Okay, so this is the discussion about. So this is also important question difference between A and FM. Okay, so please go through this. Any doubt is there? You write in the comment box. Like, share, subscribe. Thank you. Thank you very much.